When we're looking at Beer's law, we're really looking at how a solution absorbs and blocks certain wavelengths of light. We do that by shining light of a very specific wavelength through a solution in a machine, and we get a detector that says what percentage of light comes out. It's pretty straightforward. If we have a colored solution or a cloudy solution, some light will be blocked. Now it's interesting, it's not every wavelength of light we shine through that will block. Some wavelengths will go through 100%. So we have to find the right wavelength, often called, it's the wavelength that gets absorbed is lambda max. There are certain frequencies of light that get absorbed and others that don't. So if you have a green solution, some light will go through and other colors will not. So we want to kind of figure out which wavelengths do get absorbed and study those. Once we start looking at how the light gets through the solution, we can get a linear relationship, and we talk about absorbance, how much light gets absorbed. It's a little different than percentage. There's a calculation that gets involved in the machine. It's related to the percentage that comes through. But essentially what we're looking at is a relationship between absorbance and concentration. If you were to take a solution of light and you had 4 samples, so 0 molar solution does not absorb any light, so 0, 0 is always a point. And we were able to plot and say, hey, a solution 1 absorbed this much light, solution 2 absorbed this much light, solution 3, whatever they are, the molarities are, absorb this much light. You start to see that there's a linear relationship between those. Now, what does that allow us to do? That allows us, once we have known solutions and known absorbances, that we really have any absorbance for any solution of this chemical, where we can say, what if the concentration was over here? How much light would it absorb? It should be right there. But the real power of this goes the other way. If you have a solution of an unknown molarity, you can put it in the spectrophotometer and say, hey, it absorbed this much light. Then you know what the solution molarity is. Or it absorbed this much light, and you can kind of say, oh, the molarity is this much. So this actually gives us a way, by figuring out how much light gets absorbed by the solution, this actually gives us a way to figure out molarities of unknown solutions based on the absorbance. And there's a lot of different practical applications of that, but that's the idea. Once we use known solutions to get the relationship, we can then use it to solve for unknown molarities by taking absorbances of samples that we don't know.